Hello everyone, here is Afrasiab. Today we are going to solve Cambridge IGSE Physics, Paper 4 Theory Extended, held on May-June 2020. Paper code is 0625 with variant 42. So let's start from question number 1. Question number 1. Figure 1.1 shows the speed-time graph of a person on a journey. On the way he walks and then waits for a bus. He then travels by bus. He gets off the bus and waits for 2 minutes. He then walks again. His journey takes 74 minutes. So total time is 74 minutes. So here is the graph. On the x-axis we have taken time and it is taken in minutes. While on the y-axis we have taken speed and it is in kilometer per hour. So part A. For the whole journey calculate the distance traveled. So we have to calculate the distance traveled from 0 to 74 minutes. We know that the area under the graph is equal to the distance traveled by the body, and you can see from here that these are rectangles. It's also a rectangle and it is the third rectangle. The area under this must be equal to the distance traveled by the body. So if I consider this point, it is at 5 meter per second, while this point is at 20 minutes. So first of all, I write here total distance will be equal to area under graph. So we have to calculate area. Next, I consider these 2 points. At that, speed is 40. I write here 40, while the time is 30 and 50. So total time here will be 20 minutes. Here time is also 20 minutes. And it is 5 kilometer per hour. On the third rectangle, you can see that it starts from 52. It starts from 52 and ends at 74. So the total time will be 22 minutes and at that point the speed is 6. So it is 6 kilometer per hour. First of all, we have to change kilometer per hour into kilometer per minute, or we have to change time that is given in minutes into hour. So we know that in 1 hour it is equal to 60 minutes. When we have to change minute into hour, we multiply by 1 over 60. So 1 minute is equal to 1 over 60 hour. So I am going to change the time that is given in minute into hours. I just multiply that value with 1 over 60. So when I calculate the area of this, I just multiply 5 multiply the time here is 20 and then I divide it by 60. Here time comes to be in hour plus for second the speed is 40 multiply by time is again 20 minutes, 20 divided by 60 plus for the third rectangle speed is 6 multiply by time is 22 divided by 60. It is the total distance. So after solving I get it comes to be 17 kilometer. I represent it with D, so the distance comes to be 17 kilometer. So I write here 17. Part 2. The average speed. We have to calculate the average speed, and we know that average speed is equal to total distance divided by total time. Here you can see that the total distance that is covered is 17 km. As we have calculated, it comes to be 17 over. Time is 74 minutes. So first of all, I change this minute into hour by multiply it 1 over 60. I write here 74, it is in minutes, multiply by 1 over 60. Then it comes to hour. After solving, I get 14. The unit will be no. The distance unit is kilometer, and I have to convert this time into hours. So its unit is 14 km per hour. The average speed comes to be 14 km per hour. Moving towards other part of this question. No. Part B. State and explain which feature of speed time graph shows acceleration. We know that acceleration is represented by A. It is equal to change in speed over time. And in the speed time graph, the gradient gives us acceleration. So when I find out the gradient of the speed time graph, first of all we also have to state it. That's why I write here gradient, and gradient must be equal to change in speed per time. So you can see here that this formula and this formula both are equal. We can simply say that the gradient of speed time graph gives us acceleration. Part C. State and explain the acceleration of a person at time 40 minutes. So we have to explain the acceleration of a person at 40 minutes. Now we go back to the graph and see that at 40 minutes, it is at this point, it is 40 minutes. You can see that speed is not changing, and it is a horizontal line, means that its gradient is equal to 0. So when the gradient is equal to 0, we know that gradient of this graph is equal to acceleration, as when gradient is equal to 0, then acceleration also be equal to 0. It means that the acceleration in this case is equal to 0. So I write here at t is equal to 40 minutes, line is straight horizontal. Means that gradient equal to 0. So acceleration also be equal to 0. Question number 2. Figure 2.1 shows a train. The total mass of the train and its passenger is 750,000 kg. The train is traveling at a speed of 84 meters per second. The driver applies the brakes and the train takes 80 seconds to slow down to the speed of 42 meters per second. Part A. Calculate the impulse applied to the train as it slows down. Here we have to calculate the impulse, and we know that impulse is equal to change in momentum. I write here impulse is represented by I, and it is equal to change in momentum delta P, and momentum is equal to the product of mass and speed. Here we are dealing with change in momentum, that's why change in momentum is defined as the product of mass and change in speed. So I write here m delta V. Mass is given as 750,000 and the change in velocity is equal to 84 minus 42. It comes to be almost 42. So total impulse comes to be 3.2 into 10 की power 7 Newton second. The unit of impulse is Newton second. So I write here 3.2 into 10 की power 7. Part B. Calculate the average resultant force applied to the train as it slows down. Here we have to calculate the average resultant force, and we know that impulse I is equal to the product of force and time. Here we have to calculate this F. F comes to be I divided by T. Impulse we already calculated, its value is 3.2 into 10 की power 7 divided by time is given, that is 80 seconds. So I write here 80, and the resultant force comes to be 3.9 into 10 की power 5. The unit of force is Newton, so it comes to be 3.9 into 10 की power 5. So I write here force is equal to 3.9 into 10 की power 5 newtons. Part C. Suggest how the shape of train helps it to travel at a high speed. First of all, you see this train, and its shape is a streamline, and it is the best down shape that reduces the air resistance. So I write here the streamlined shape of train helps in reducing air resistance experienced by train. Part D. The train took 80 seconds to reduce speed from 84 meters per second to 42 meters per second. The time for this is 80 seconds. Explain why with the same braking force, the train takes more than 80 seconds to reduce its speed from 42 meters per second to 0. So, because when a train is moving at a slow speed, then there is less air resistance against it. And I write here slower speed means that air resistance is low. It is small, and this time when you are trying to reduce your speed, so the higher the air resistance, this causes easier for you to slow down. But at lower speed, there is less air resistance, so you need more time to reduce the same amount of speed. For less air resistance, less force helping it to slow down. It means that for lower air resistance, less force helping it to slow down. So, it is simpler reason that when you're trying to reduce your speed, the air resistance increases, the easier it is for you to slow down. But at lower speed, we know that there is less air resistance and you need more time to reduce the same amount of speed. So I write here there is less air resistance at slow speeds. Next part, the E. On a wet day, the train travels a greater distance before it stops along the same track. The train has the speed of 84 meters per second before the brakes are applied. Suggest a reason for this. So, if you consider bikes and motorcycles, on a wet day, when you stop, you are gonna travel slightly further than you are usual. This is because the roads are wet and slippery. Because roads are wet and slippery. This reduces the air friction and you slide along the roads. If we apply this to the train, we say that there is a friction between rail and train. Due to the wet day, this friction reduces, so it travels a greater distance before it stops. So the reason for this is that the friction force between the rail and train reduces and it may slide. So I write here the friction force between rail and train reduced and it may slide. Question number 3, part A. A solar panel receives energy from the sun at the rate of 5.0 kilowatt. So power is given as 5 kilowatt. Thermal energy is transferred from the solar panel to water with the efficiency of 20%. Efficiency is 20%. The cooled water of mass 15 kg enters the solar panel every hour. Specific heat capacity of water is 4200 joule per kilogram per degree C. Calculate the temperature increase of the water. Here we have to calculate the increase in temperature of water and we are given efficiency, power, mass and time. We know that when we are given specific heat capacity, we usually use the formula E is equal to mc delta T. Here E is the energy, m is mass, C is specific heat capacity, and delta T is change in temperature. Here we have to calculate the temperature increase, means that we have to calculate the change in temperature, and we are given specific heat and mass also given, but we don't have energy. So first of all we have to calculate energy. When efficiency is given, we know that efficiency is equal to E is equal to output over input. E is equal to output power over input power. So efficiency is given as 20%. I write here 20%. It will be equal to, we have to calculate the output power because the input power is 5 kilowatt. It means that it is 5,000 watt. So I write here power, that is output power, divided by 5,000. Then power comes to be 5,000 multiplied by 20%. It means that we have to write it as 5,000 multiplied by 20 over 100, and after simplification we get power comes to be 1000 watt. We also know that the power is equal to energy per unit time. Here we have to calculate energy. Energy is equal to P cross T, and power we have already calculated, it is 1000 multiplied by time. So here they mentioned that every hour, it means that time is equal to 1 hour, and we know that 1 hour is equal to 60 minutes, and then 1 minute is equal to 60 seconds. So it comes to be 3600 seconds. So I write here 3600. Energy comes to be 36 joule. Energy comes to be this. Then we have to put this value of energy into this formula to calculate the temperature change. So I write here delta T is equal to E over mc, and E is given as mass is given as 15 kilogram, multiplied by C is 4200. When I simplify, the temperature comes to be 57 degrees C. So the temperature increased by 57 degrees C. Part B. Now state and explain one advantage and one disadvantage of heating the water in a solar panel as compared with heating the water in coal burning boiler. So we have to state and explain one advantage and one disadvantage when we heat the water into solar panel instead of heating the water into coal burner boiler. So advantage of this use of solar panel is that it is a renewable source of energy. It means that we can use the solar panel again and again to get the energy, and there is no air pollution caused by this. So I write here renewable source of energy. Renewable source of energy. and other is no air pollution. It does not cause any air pollution. Explanation is that it is a reliable source of energy and it gives better environment, and it is better for environment. So I write here reliable source of energy and it is, as it does not cause any air pollution, that's why it's better for environment. Now we have to state the disadvantage of use of solar panel. So we know that it's very expensive and it works only in the daytime, because it works when the radiation from the sun falls over it, then it store energy. But at the night there is no sun, that's why it does not work at night. We can simply say that it is not available at night and it needs a proper roof space. So I write here expensive to install. Other is not available at night. And it's need a roof space. Explanation: it is inconvenient and its availability is limited. And only those with enough space can have it. Because it requires a proper spacing. Question number 4. Figure 4.1 shows a liquid in glass thermometer without a temperature scale. The liquid inside the thermometer has a melting point of minus 39 degrees C. You can see here is a thermometer and there is a liquid inside it. Part A describes simple experiment to mark the positions of fixed point on this liquid in glass thermometer. So what we will have to do in the first step, we have to place it into the melting ice. Then you will see a point where the liquid inside the thermometer is called beads. Stop moving. And we also have to remember that there is no change in temperature in melting ice, because all energy is used up to change its state. So when the bead inside the instrument stops moving, it means that it has reached melting point. So when beads stops moving, then it means that melting point has reached. Second, we have also the mark the position of the second fixed point. Then in the second, we have to put this into the steam. That is above boiling water. Again, beads inside the thermometer will stop moving. Then its water boiling point. When beads stop moving, it means that boiling point reached. And we have to mark this temperature. We know that the melting point is 0 degrees C, while the boiling point is 100 degrees C. So, I am writing here the step. First, put the thermometer in melting ice. When bead has stopped move, then mark that point as 0 degrees C. It's the melting point. No. Again, put the thermometer in steam. Above boiling point. Again, when the bead has stopped moving, mark that point as 100 degrees C. In the second part B, a scientist is measuring temperatures at the South Pole. These temperatures have a minimum value of minus 90 degrees C. State why the liquid used in the thermometer in figure 4.1 would not be suitable for the scientist. So we have here to explain the reason. Now from the part 1, we can see that first the boiling point is minus 39 degrees C. And if this is brought to the South Pole, where the minimum temperature is minus 90 degrees C. So at this temperature, it's going to freeze and would not be able to in liquid state. So I'm writing here when this is being to South Pole, where the minimum temperature is minus 90 degrees C. At this temperature, it's going to be freeze and would not be in a liquid state. So beads would freeze solvent would not be in liquid state. You have to complete this on just this line. Part C. State a design change that increase the sensitivity of a liquid in glass thermometer. So, how we can increase the sensitivity of liquid in glass thermometer? To increase the sensitivity, you can use a thinner tube. In this way, you can easily spot small change in temperature. So, first of all, use thinner tube. Or use liquid that expand more per unit change in temperature. Use liquid that expands more per unit change in temperature. By using this, liquid becomes more sensitive and travels more from the same temperature change. Part 2. Increase the range of a liquid in glass thermometer. How we can increase the range? So, to increase the range, it's simple. Just get a longer tube so that the liquid can travel more up and down in the thermometer. So, just use the longer tube. Part D. State the property of liquid which ensure that the scale on a liquid in glass thermometer is linear. So we have to state the property that shows that the scale on a liquid glass thermometer is linear. Only the certain types of liquid with this property can be used in a liquid in glass thermometer. It's when they expand uniformly with temperature. When they expand uniformly with temperature. Now, what does this mean? It means that if I expand by 1 cubic centimeter for 1 degree C, any liquid whose expansion is 1 cubic centimeter for 1 degree C change, then it need to expand by 10 cubic centimeter when its temperature change is 10 degrees C. You can see here that there is an equal change. Means that first of all temperature is 1 degree C and then I increase to 10 degrees C. Then its expansion also increase and it becomes 10 cubic centimeter. So the property which shows that the scale on a liquid glass thermometer is linear is the expand uniformly with temperature. Question number 5. Figure 5.1 shows crest of a wave approaching a barrier where the wave is deflected. You can see here that it is the barrier and it is the direction of travel of wave. These are the crusts. So, part A. On figure 5.1, draw 3 crusts of the deflected wave. Here we have to draw the 3 crusts of the deflected wave. So, what will we have to do? First of all, to draw the crust of reflected wave, we have to draw the normal lines. So, I use the ruler and draw the normal lines at this crust. We have to draw the 3. That's why I also draw 3 normal. No, I have drawn the 3 normal, and we know that when a wave is reflected, it has 2 angles, angle of incidence and other angle is angle of reflection. Both of these angles must be equal. From here in the figure, it is the angle of incidence. I represent it with I and it with R, and on the other side there is the angle of reflection. But both of these angles must be equal. So the angle of reflection may be at this point when both of these are equal. So I simply draw a line that passing through this point and in such a way that the angle of incidence must be equal to the angle of reflection. So again I use the ruler. So I am drawing this line. So you can see here that these are the 3 crusts of the reflected wave. Then as we have drawn them, then again we have to remove or erase all of the normal ray. So I will erase these. I also have to erase this one. Okay. So these rays are basically shows the 3 crusts of the reflected wave. So I am going to write the step here. What I have to do. First, draw the normal. Second, we have to draw the reflected line by identifying that what is the angle of incidence. Determine the angle of incidence. Third step, draw a reflected line. In the fourth step, we have to make sure that the wavefront must be parallel to each other. It means that these are the wavefront. They must be parallel to each other. And the gap between these wavefronts will be same as well. Make sure that wavefronts are parallel to each other and gap between them are same. At the last point, we have to erase all the normal rays. Erase all normal rays. So we have to follow this step to draw the crust of reflected wave. Second part. Part B. The wave has a wavelength of 36 cm and a speed of 1.2 meter per second. Calculate the frequency of the wave. Here we have to calculate the frequency when wavelength and speed is given. So wavelength is equal to, it is represented by lambda and it is equal to 36 cm. The unit of lambda here is given centimeter, but its standard unit is meter. So I convert the centimeter into meter by dividing it by 100 and it comes to be 0.36 meters. Speed is also given. It is equal to 1.2 meter per second. Now I have to use the formula V is equal to F lambda and we have to find out frequency. It will be equal to V over lambda. V is 1.2 divided by 0.36 and it comes to be 3.3 Hertz. The unit of frequency is Hertz, so I write here 3.3 Hertz. Part C. Complete the following sentences. An echo is the name for a reflected dash wave. So, the echo is the name for a reflected sound wave. The waves that form an echo are type of longitudinal wave. So we know that longitudinal waves are the waves in which the particle vibration motion is parallel to the direction of travel of wave. So the longitudinal wave are made up of dash and rarefactions. So the longitudinal wave is made up of compressions and rarefactions. Question number 6, Part A. Figure 6.1 shows an arrangement of glass prism inside a box. The angle of the prisms are 45 degree, 45 degree and 90 degree. You can see here it's a arrangement and this is prism 1 and it is prism 2. The angle of these prism are 45, 45 and 90. First of all, we have to specify these angle. You can see for the prism 1, this is 90 degree. This angle is 45. It's also 45 degree. For the prism 2, it is 45 degree. It's again 45 and it's 90 degree. So in the question we have asked, this is a device used to view objects that are behind a wall. The incident ray of light undergoes total internal reflection in the prism. On figure 6.1, complete the path of the ray through the device and show the rays are as it emerges from the box. Here we have to show the path of ray through the figure. So first of all, you can see the figure. There is an incident ray of light that hits the prism 1 and when you look at the prism, you will saw something behind this wall just like this. And because incident light is coming from prism 1 and entering into the prism 2, so I am going to draw the line that the incident ray hits the prism 1 completely inside it. So this is the incident ray, and it also hits the prism 2 perpendicularly. The angle between them must be equal to 90. So I draw a line from prism 1 reaching the prism 2 and hitting it. Then I also join it with other side. So this is the path of the light ray, and you have to make sure that this is a straight line and hit the prism 2 at angle 90. So moving towards the other part of this question, show that the refractive index of glass with a critical angle of 45 is 1.41. So the critical angle is 45 and we have to show that 1.41 is the refractive index of glass. We also know that refractive index is represented by small n and the critical angle I represent it with C. So n is equal to 1 over sine function of critical angle. Here C represents this angle, and when I put the values here, it comes to be 1 over sine of 45 degree, and its value comes to be 1.41. So the refractive index of glass comes to be 1.41. Question number 7, part A. A student makes a transformer that uses an alternating current AC supply with an electromotive force EMF of 12.0 volt to induce an output potential difference PD of 2.0 volt. The student is provided with two lengths of insulated wire and the U-shaped piece of iron shown in figure 7.1. You can see this is the figure 7.1 and the U-shaped piece of iron is also be shown here. Part 1. Complete and label figure 7.1 to show the transformer connected to the supply and output from the transformer. So, we need to make a transformer out of this iron and two lengths of insulated wire. So primary and secondary coils should be around these two parts of the iron. We know that transformer consists of primary coil, other is secondary coil. And you see from the question that the input is 12 volt while the output is 2. Input is 12.0, it is greater than 2.0, which means that the primary potential difference is greater than the secondary potential difference and it's a step down transformer. In step down transformer, the number of turns in primary is larger as compared to number of turns in secondary. So I will draw it. It is a first, end. So it's a primary coil because the number of turns here is larger. And it's the secondary one. Part 2. Explain the function of piece of iron in the transformer. Here we have to describe the function of iron that is used in the transformer. You may notice that transformer always consists of a piece of iron where coils are wound. They are to be first of all used as a magnetic field of coils. So, because it links the magnetic field of coils, and second, it have to produce the stronger magnetic field in the secondary coil, and thus these are better electromagnetic induction. So I write here, it links magnetic field of coils and secondly, it helps producing stronger magnetic field in secondary coil. Thus, better electromagnetic induction. Part 3. The output of the transformer is connected to a lamp. The current in the lamp is 100 milliampere. The transformer is 100% efficient. Calculate the input current to the transformer. Here you can see that the transformer efficiency is 100%. It means that the input power must be equal to output power. Input power must be equal to output power. And we know that power is the product of current and potential difference. So I write here I1 V1 is equal to I2 V2. We already know about the potential difference value, and now we have to find out the current I1 and we'll need to know the value of I2. We can see here the output of transformer is connected to lamp, and the current in the lamp is 100 milliampere. This means that this current is in the secondary, so it is I2. And we have to convert this current into amperes. That's why I divide it by 1000 and it comes to be 0.1. So I am putting values here. I1 is equal to I2 V2 over V1. I2 is 0.1 multiplied by V2 is 2 over it is 12, its value of I1. After simplification I get 0.017 ampere. So the current in the input coil is 0.017 ampere. Part B. Another transformer is used in a school laboratory to step down a main supply with potential difference of 110 volts to 12 volts. This transformer is mounted in a metal case. State and explain an essential safety feature required for this arrangement. So here you can see that metal case is used. It's a metal case which can conduct electricity, and so we need to earth it. It means that we have to provide an alternating path for the electricity to flow to the ground. So I'm writing here metal case need to be earthed in case insulation fails or live wire touch glass. Live wire touches case. Question number 8, part A. A light emitting diode LED is a diode that emits light when there is a current in it. Draw a circuit diagram showing an LED connected so that it is lit in series with a battery and a fixed resistor. Use standard electrical symbol. In order to draw the circuit diagram, we have to know the symbol of LED, battery and fixed resistor. So I am going to draw these symbols. LED is represented by the following symbol. Now the symbol for battery is and for fixed resistance we have to draw the symbol of resistance and put an arrow over it. So in order to draw the circuit diagram, I used ruler and in the question there is given that all of these are connected in series. I have to draw the battery here. So it's a battery and there is also a fixed resistor in series with this. Here I have to draw the fixed resistor. And put arrow above it. At the end I have to draw the LED. So I again use the ruler and join these two terminals. So basically it is a circuit diagram for the given question. Part B. The potential difference across the LED when it is 3.1 volt. The current in the LED is 0.030 ampere. Calculate the value of resistance of the LED when it lit. So here we have to calculate the resistance, and by using Ohm's law we know that V is equal to IR. Here we have to find out the value of R. It is equal to V over I. Potential difference is 3.1 divided by current is given as 0.030 and we get 100 ohms. The resistance comes to be 100 ohms. So moving towards the next part of this question. Part C. Figure 8.1 shows a power supply of EMF 10.0 volt. You can see here it's a power supply and the EMF is 10.0 volt. Connected in series with the lamp and a heater. It's the lamp and it's the heater. The potential difference across the lamp is 2.1 volt and the current in the lamp is 1.5 ampere. So the value of current and potential difference in the lamp is given, which is equal to 1.5 ampere and 2.1 volt. No. Calculate part 1. The resistance of the heater. We have to calculate the resistance of this heater. By using Ohm's law, we know that V is equal to IR. In order to calculate the resistance, we have to know the value of potential difference and current. And in the question it is given that this is a series circuit. It means that in the series circuit, we know that the potential difference changes, but current remains same. I1 is equal to I2, it is equal to I in series circuit. As the current remains same, so the amount of current that passing through this lamp will be equal to the amount of current that passing through the heater. That's why here current is also 1.5 ampere. And we have to find out the potential difference in this heater. And I again use this formula V is equal to V1 plus V2. Here V is the potential difference of this power supply. I write here V is equal to V1 plus V2. Here V is 10.5 minus, let's suppose V1 is equal to 2.1, that is the potential difference of lamp. So it will be equal to 2.1 plus I write it V2. So it comes to be 10.5 minus 2.1 is equal to V2, and V2 comes to be 8.4 volt. So the potential difference we already calculate and the current is also calculated. It means that current here will be equal to 1.5 ampere. put the values in this formula, it comes to be 8.4 over 1.5, R comes to be 5.6 ohms. So the resistance of heater comes to be 5.6 ohms. Part 2, the power of the heater. Here we have to calculate the power of this heater. So it is the heater, we have to calculate the power of this. And we know that the formula of power is P is equal to product of potential difference and current. So here we know the value of potential difference and current. I is, we calculate it's 1.5 multiplied by potential difference is 8.4. So power comes to be 12.6 watt. 12.6 watt. The unit of power is watt. Question number 9, part A. Complete the truth table shown in table 9.1 for a NAND gate. We have to complete this table for the NAND gate. First of all, we have to know what is NAND gate. So NAND gate is a combination of AND plus NOT gate. When we apply NOT gate over AND gate, we get NAND gate. And what is AND gate? AND gate, when both of the inputs are high, output will be high. When both inputs are high, output will be high. Otherwise, output will be low. So we have to complete this table according to NAND gate. First of all, the two inputs are given, input 1 and input 2. We have to apply here AND gate. In the AND gate, you can see here at the last row, where both inputs are 1, 1, output will be 1. For all other combination, output will be equal to 0. And when we get AND gate, we have to apply the NOT gate over it to get the NAND gate. In the NOT gate, we convert 1 into 1 and 1 into 0. If there is 1, then it changes into 0, and when there is 0, it changes into 1. So I write here 0 changes into 1, 0 into 1, 1 and 1 changes into 0. So these are the outputs of NAND gate. Part B. The circuit shown in the figure 9.1 contains two different types of gate labeled X and Y. So there are two different types of gate. Here it is X, and again there is X, and it is Y. And you can also see that the inputs are A and B. The output of X first of all is C and Y is D. Then C and D are the inputs for this X, and it gives output E. So in the part B, we also given a truth table. And table 9.2 shows a partially complete truth table for this circuit. So inputs are A and B, intermediate points that are outputs C and D, and both of these outputs are the input of last X gate and gives the output E. We have to complete this table. Part 1. From table 9.2, deduce the name of logic gate Y. Here we have to tell that the logic gate Y, its name what is. So you can see here that the output of Y is represented by D. So I am considering here D. You can see here the inputs in the first case is 0 and 0, and it gives output 0. When inputs are 1 and 1, output is 1. For all other cases, output is low. It means that it is a NAND gate. Sorry, it is a AND gate, in which both inputs are 1, 1, then output will be 1, otherwise it is 0. So Y is a AND gate. So I take here AND. Part 2. Complete the truth table in the table 9.2. Here I have to complete this table and I again go back to the circuit. So you can see here A and B are the inputs. Both of these combine to give C. That is the output of X. So I don't know that what gate is X. We have to determine it. And you can see from here the output of X is C. So I am considering C. And you can see here that 1, 1 and 1. If any one of the input is high, you can see here that first input is 0, 0, then output is 0. In the next, input is 0 and 1, output is 1. Again, for inputs 1, 0, output is 1. And for input 1 and 1, output is 1. It means that it is a OR gate. In the OR gate, if any one input is high, output will be high. So I simply write here OR, and this X is also OR gate. No. You can see from here that C and D combines to give X, and X is the OR gate. It means that we have to apply OR gate on C and D. So I write here C or D. Then when I apply OR gate over these, I get 0 and 0 gives 0, 1, 0 gives 1, 1, 0 also 1 and 1, 1 also 1. So these are the output of E. Next part. Part C. There is a current of 3.0 ampere in a copper wire. Calculate how many electrons pass through the copper wire in every 60 seconds. The charge on an electron is 1.6 into 10 to the power minus 19 coulomb. Here current is given and we have to calculate the total number of electrons that passing through the copper wire in 60 seconds. So as we know that current is defined as the rate of flow of charges. It is equal to Q over T, where I is current and Q are charges and T is time. We have to separate this Q. Q is equal to I cross T. And we also know that charge Q is equal to the product of N and E, where N is the total number of particles and E is the charge on one particle. So the charge Q will be equal to N and E. So here we have to calculate how many electrons. It means that we have to calculate number of electrons N. So I write here Q is equal to NE. It is equal to I cross T and N is separated. I cross T divided by E. I am putting values here. Current is given 3.0 multiplied by time is 60 seconds divided by E, that is the charge on electron is 1.6 into 10 to the power minus 19. So after solving it, we get 1.1 into 10 to the power 21. So the total number of electrons will be 1.1 into 10 to the power 21. Question number 10. Figure 10.1 shows a vacuum tube with a radioactive source. So there is a radioactive source inside this tube, which is represented by this. The radioactive source emits alpha particles, beta particles, and gamma rays. There is a very strong magnetic field between the north pole and the south pole of the magnet. These two are the poles of magnet and they create a very strong magnetic field. Part A. The lead cylinder has a narrow central hole. State and explain the effect of lead cylinder. So you can see here that this is the cylinder. This hole is a cylinder and this is a narrow hole. So explain the effect of the lead cylinder. So we have to explain its effect. Since it has a narrow central hole, beam will be narrow because it is very small. The beam will be narrow and emits in a straight line. You can see from here that the beam is coming in a straight line. Also the radiation in the other direction will be absorbed by this lead and so you will have a clean emission. So I am writing the beam is narrow and straight that is coming out of this lead cylinder. The radiation in other side radiation in other sides or other direction will be absorbed. Part B. Describe the path of alpha particle, beta particles and gamma rays as they pass through the magnetic field. Explain your answer. Here we have to describe the path of these three particles and also gamma rays. So, we know that Fleming left hand rule. If we consider our left hand, arrange it in such a way that our forefinger, middle finger, and thumb, they all perpendicular to each other. Then we have to arrange it in such a way that if our forefinger represents the direction of field, while our middle finger represents the direction of current, then our thumb represents the direction of motion. So you can see in this diagram that the magnetic field will be from north to south. It will be in downward direction and the current is flowing in this direction. So magnetic field is downward. It's magnetic field and it's the direction of current. Then we have to apply the Fleming left hand rule. The direction of motion will comes to be out of phase towards you. Then direction will be towards you. So first of all, we have to know what is alpha particles, beta particles and gamma rays. So alpha particles are actually helium nuclei and these are positively charged. while the beta particles are negatively charged and it is electron. These are represented by 0 and -1. And gamma rays are basically the electromagnetic radiation, and these are neutral, they don't have any charge. So, when the alpha particles passing through the magnetic field, then the direction of motion will be out of page. So I am writing here, direction will be out of page. It's the direction of motion. And we know that the alpha particles move in the direction of current. That's why its direction of motion will be out of page. And according to Fleming left-hand rule, the current is moving out of page. That's why the alpha particle move in the same direction. As that of current. And beta particles are negatively charged and they move opposite to alpha particle. It means that they move in the direction opposite to the direction of beam. So also in this case it will be move into the page because they move opposite to alpha particle. So I am writing here towards the page. And they move opposite direction to electric current. Part third, we have to also specify the gamma rays, and we know that these are neutral. That's why their direction is not specified, not towards the page, not out of page. So they continue going straight because they continue to going straight and why this happens? So because these are uncharged.